So now I think everybody's here who is planning to be here. So with that, I asked if Jonathan is around.
I'm
Perfect. Good to see you.
good to see you too.
Yeah, so I think share your screen, and you know how this works. Share your screen. Take it away. We see a screen, great.
Can you see my screen?
Yes, and now
Oh,
it's
good.
yeah, perfect. Take it away.
Okay, good stuff. Well, look, many thanks for having me here to the Smart Cities eBazaar. My name is Jonathan. I'm the CEO at a company called Univrses. We're based up here in Stockholm, in the middle of Platten. We're experts in something called computer vision. We work with companies like Volvo Cars to make their cars more autonomous. We process images from those cameras to help the cars understand where they are on the road and what's around them. We also work with companies like ABB in the mining sector to do the same thing with robotic systems, with Husqvarna as well, with domestic robots. So it's all about perception and computer vision. About 2 years ago, we started to do something a bit different. We noticed that there were some problems in the city that we were working with, trying to understand. For example, this one, did you know that about three-quarters of the cars driving around the city, up to about three-quarters, are actually just cars looking for parking spots. And so there's a real problem with cars finding out where they need to go in order to park. Actually, the cost of road damage, potholes and cracks and this kind of thing is immense. That's the cost in 2019 and the annual cost in 2019 for the US to repair their roads. It's about 1 billion SEK here in Sweden annually to look after the roads and repair them that way. This is a huge cost, and actually one of the things that's causing that cost is knowing where all this damage is. And it's not just a cost, there's also a human element as well. Again, in the States, there are about 33,000 deaths per year from road accidents, and about a third of those are caused by poor road quality. So we started thinking about our computer vision technology and started to think how we could start to solve some of these problems. So what we've done now is take all of that computer vision, all of that image processing, originally developed for autonomous cars, and squeeze them down to run on a smartphone, all of those devices that you have in your pockets today. And what we're working now with different fleets of vehicles that are already operating in the city, taxis, garbage trucks, buses, these kinds of vehicles. We put those smartphones running our computer vision in the dash of those vehicles, and we process the camera images, not to make those vehicles autonomous anymore, but just to turn them into data harvesting agents. And we send all of that data up to the cloud. It's then all it appears on our dashboard, and we send that dashboard to city managers, fleet managers, so that they understand in more detail what's happening in the city, so they can make better decisions, deploy resources more effectively, save time, save money, save lives. Because it's a camera, it's a very rich sensing modality. We can detect lots of different things. This is really the tip of the iceberg, we think, but it gives you a flavor for the types of features we can detect in the city. We've started at very specific spaces, traffic signs, roadworks, and potholes and cracks. Here in Stockholm, they have 4,000 roadworks each year. The city knows exactly where those roadworks should be. They have absolutely no idea where they really are. And so they have very little idea when the contractor started on time, if they finished on time, they're adhering to safety regulation. We're going to be coming out soon with traffic and pedestrian density, so detecting numbers of vehicles, numbers of people, just to give an indication of traffic flows and pedestrian flows. And we're working to develop parking detection as well, so the cameras on these vehicles can detect free parking spots, illegal parking, and can guide drivers appropriately. All of that data is sent up to the cloud, and personal data is anonymized, organized into channels, and then you can access the roadwork channel or the traffic sign channel. So we've started to work now with Stockholm Stad. You can see they're particularly interested in road damage. You can see two videos playing on the screen. On the left-hand side, there's a live feed from the car detecting the road damage. We've classified the road damage into different 1 to 5 scale. All of that's sent to the cloud, and then you can see our dashboard operating on the right-hand side. As I say, we process all of our images out at all the computer vision happens on the phone. So when you see the pictures in the dashboard, that's just a confirmation image. Any personal data is removed from that image, and so you don't see people's faces, you don't see people's license plates. But what the city now has is an overview, that colored coded map of where the road damage is in the city, and then they can respond accordingly. You can see there the license plate on that vehicle with the capture is blurred out as well. So this now, the Stockholm Stad is using the system. We have about 35 vehicles driving around Stockholm at the moment, 20 taxis. We have got 10 municipality vehicles and up to 8 or 9 Trafikverket vehicles as well. We're also working with Trafikverket. They have an interest in traffic signs. They're actually working with the speed camera department. So there you can see on the left-hand side of video again, we're detecting the traffic signs in the image plane. And as they're detected, you can see them appearing on the map. Because it's all happening at the edge, out on the phone, it all happens in almost real time. And so you'll see pretty soon in the video when on the left-hand side, when it comes up, we detect the traffic sign and then it appears on the map, as you can see just then. All of that information, I'll just run that back to the beginning, it appears on the map. And this means that Trafikverket now can go and be aware of what assets they're responsible for in the environment. There are actually 2,200 speed cameras in Sweden, and in order for the photos from those cameras to be admissible, they need to inspect the signs once a week. So that's a big cost for them. So now they can do this automatically. They do it, their current processes are very manual. This automatic gives good data quality, and when the police call them up to ask if the camera is admissible in court, they can now provide this information to make it so. I think it's worth, because we're obviously putting a camera in the public environment, one of the things that's absolutely crucially important is privacy, GDPR compliance, being respectful of personal data. The system is fully GDPR compliant. This is because we process all of the images out at the edge, so no personal data leaves the device. It's just simply the location and type of the traffic sign or the quality of the road. What we do though is send what we call this confirmation image. So when we detect a traffic sign, we send the picture. This is not for any technical reasons. This is just so the human being can look at something on the map and then see a picture of it. We may happen to get some personal data. It is an unintended consequence. We don't want it. We don't manage personal data in any kind of way. And as you can see, we blur it out, so we remove it straight away. So this is something that we're beginning to scale now. This is some of the latest work we're doing. On the left-hand side, you can see the parking spots being detected. We're also doing the pedestrian and vehicle density I spoke about. You can see a live count taking place in the top left-hand corner. So again, this is computer vision running out on the edge, on the device, and this is starting to be used now, particularly in Zurich. We've got some deployments taking place with the city of Zurich and Co-op down there using their vehicles, and they can then use this information to understand some vehicle flows through the city, to understand the pedestrian flows through the city, and this helps inform their decision-making and how to optimize their operations in a better way. Yeah, in summary, really, I mean, this is where we are. It's a fantastic saving for the city. It means that their current processes, which can typically take many weeks, are now very much shorter. And the crucial part here is that there's no special hardware, there's no special vehicles. They take advantage of the vehicles that are already out in the city, the devices that are already in your pocket. And what that means is that they're able to turn all of their existing assets into data harvesters and make better understanding of the environment that they're responsible for. As I say, make better decisions, save time, save money, and save lives as well. Thank you very much for listening. If you have any questions, happy to try and answer them.
Perfect, Jonathan. Thank you so much. To the audience, you can place questions in the chat. I'll try to ask them to the speakers if you like, but I don't see any now. But Jonathan, can you just tell us briefly about kind of the size and shape and stage of your company?
Yeah, of course. So we're about 45 people now. And so we, as I say, about half the company works with autonomous vehicles, developing computer vision and perception for that industry. That's where we work with high-end cameras, high-end processors, and achieve centimeter level accuracy in the feature detection that we're carrying out for those vehicles. You need that because you're closing a control loop. You're steering the car and braking the car based on the data we provide. And then about half the company is working on the technology I've just shown you. We make trades because we've taken the same technology and adapted for a lower end hardware platform, the smartphone, but actually the application space doesn't require that kind of centimeter level accuracy. You don't need to know where a pothole is to within centimeters. You just need to know approximately where it is. Actually, our accuracy is very good. We're getting the traffic signs to within 1.5 meters on average. That means we're often a lot better than that. And it's so much so that actually the two worlds are beginning to come back together. One of the things autonomous cars need is up-to-date maps so that they can navigate and appropriately. And of course, one of the things we can do is provide data back to them as well. So there's some interesting developments going on in that space.
We have a question for you, which is very relevant. So can you explain the business model with your solution in cities?
Yeah, of course. So we actually, when it comes to the cities, we are selling, it's a software as a service business model. They provide their own phones, their own data plans, their own vehicles, their own laptops, and we sell the software and they subscribe to that software. They then access the different channels of data, the roadwork channel, the traffic sign channel, or the pothole channel, much like you subscribe to Netflix or Spotify, and there's a monthly fee paid a year in advance that they then subscribe, depending on how many channels they subscribe to, the fee is adjusted. And that's for data that they collect themselves. There is also the possibility for them to cities and different fleets to access the data that the other providers are generating. So, for example, you might have Stockholm starred vehicles collecting data. You might have a taxi fleet collecting data, and the two data sets can be transferred to the other to give a richer view of what's happening in the city.
Cool. I have another question for you. What is the max speed of the vehicles shall respect to get your systems working properly?
Yeah, no, it's a great question. Sorry, the real answer is it depends. If there is good light and the features are very visible, like traffic signs, which are designed to be visible, you can go very fast. The detection is not inhibited by the speed, really. It's when the light goes down. For example, when the lights go out in the middle of the night, we will fail on the detection, and there you have to go much slower.
Yeah.
For the detection to take place.
Super. I think we have to stop there. Thank you so much again, and I hope you can stay, because afterwards we will have a little bit of time for a chat as well, if you like. Thank you so much.